Today's video is on the mole concept.
Let's have an introduction to the mole. To do so, we'll consider a few atoms. Here we have hydrogen, carbon, oxygen, and uranium. Hydrogen has an atomic mass of 1, carbon 12, oxygen 16, and uranium 238. You could call these the relative masses if you like. Remember, we want to count by weighing particles, but our balances can't resolve atomic mass units. Atomic mass units are much too small. We need a conversion factor between atomic mass units and grams, and it's a very, very large number of atomic mass units in a gram. It turns out to be 6.022 by 10 to the 23 atomic mass units in 1 gram. This number is called Avogadro's number. It's a unit of quantity called a mole. In the same way 12 is a dozen or 2 is a pair, so Avogadro's number is a mole of something. So a mole of iron atoms is 6.022 by 10 to the 23 iron atoms, and a mole of donuts is the same number of donuts. So the value of this is to count atoms, molecules, etc. by weighing or by volume or by whatever it is, and then predict and quantify chemical reactions. So how to use it? Well, let's use an example. Here we have 23.2 grams of boron, and we'd like to know how many moles of boron atoms this is. So we'll use a unit analysis here, 23.2 grams of boron. We'll use the molar mass of boron. It's 10.81 grams boron per 1 mole. And the units come out in moles of boron. Notice we have 3 figs in this question, so that winds up as 2.15 moles of boron particles. Quite a lot of particles. In the next example, we have 5.32 moles of oxygen, and the question is, what's the mass of this sample? What does this weigh? Well, we'll take our 5.32 moles of oxygen, get the molar mass of oxygen here as 32 grams. And by the way to do that is, remember, oxygen gas is O2, so 216 atomic mass unit oxygen atoms makes a 32 atomic mass unit molecule, which is 32 grams per mole. And multiply, and you'll get this as 170 grams of oxygen gas. In this third example, we have a pellet of carbon dioxide. This is dry ice, solid carbon dioxide, with a mass of 13.42 grams. I masked that, by the way. That number is for real. And the question is, how many particles of CO2 are in this sample? Well, the molar mass of carbon dioxide turns out to be 44 grams per mole, if you count them up. So here we'll use that 44 grams per mole. And remember that 1 mole is 6.022 by 10 to the 23 particles. This is a large number of particles, and we can calculate here, and we will get a value of 1.84, it looks like, by 10 to the 23 particles after we round down to 3 significant figures. So you can see it would be quite valuable and worthwhile to get in practice calculating these things we call molar masses. So let me just get ammonia, lithium phosphate, sulfur hexafluoride, and nitrogen gas. Try to calculate those right now, and I'll do it here. Just 14 and 3, 17. For the lithium, we'll need 3 lithiums, 1 phosphorus, and 4 oxygens. Get 115.8. And for the sulfur hexafluoride, we need 1 sulfur and 6 of these fluorines here at 18.99 apiece. That'll give us 146.0. And finally, nitrogen gas here, there's 2 14s of 28.0 gram per mole. We usually use atomic masses to 1 decimal place. So anyway, we can calculate molar masses and translate back and forth between masses and numbers of particles. Need I say, this will be very useful. Anyway, listen, thank you so much. So glad to have you along on this short lesson, and have a look at the next 2 videos for more on the topic, and stay tuned for our next lesson, lesson 11, mole conversions.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!